Unit 5A, Lesson 3, Dilations and Sequencing. So we're kind of combining both of these into one lesson. This is your last lesson that we'll be doing for Unit 5, Part A. So let's start with dilations. So on your notes you have some blanks to fill in. A dilation is an enlargement or reduction of a figure. So here's an example over here on this side of the page where a photo, you have like the wallet size, the smaller ones, and then you have the larger portrait size that maybe your parents put in a frame and put up on the wall, but the wallets, you know, the smaller ones, maybe they carry around in their purse or something. All right, and dilations can create similar shapes. That means that they're the same shape but as the original, but not the same size. So this dilation is the only transformation that creates a similar figure, whereas the other three that we've learned so far, translations, rotations, and reflections, those create a congruent figure that is exactly the same size and shape, just maybe different orientation or, you know, a mirrored image, or it's turned. All right, so let's talk about scale factor. Scale factor is the number by which it is enlarged or reduced. Okay, so if it's a number that's less than 1, then it is a reduction. All right, so a number less than 1 would be like a fraction, like a half, or a third, or a fourth, or a fifth, or a sixth. It can also be numbers that are not like 1 over a number. It could be like 2/3, but those aren't as you don't see those as often as you do like a third, a fourth, a fifth, a half. Those are the most common ones. And then if the scale factor is a number greater than 1, then it's an enlargement. So if it is a scale factor of 2, that means it doubled in size. If it is a scale factor of 3, that means it tripled. And 4 means it's 4 times as big. So that means that each side is 4 times larger than the original. So whatever the scale factor number is, the new side lengths are that much bigger or that much smaller. So how do you find it? You take the coordinates of the original pre-image and the new image, and then you create a fraction, and you make sure that when you make that fraction that the new number, the prime, is on top of the bottom. So let's take a look at this first example 1. It tells us the scale factor is 3. So since it's a whole number 3, we know that that means the figure got 3 times larger. So we can look at this original triangle on the left, the small blue triangle, and we see that side AB is 2 units long. Well, side A prime B prime on the new figure on the image is 6 units bigger. Or sorry, 6 units long. So it went from size 2 to size 6. That means it got 3 times larger. So the scale factor was 3. All right, let's look at example 2. Example 2 has a scale factor of 1/3. All right, since it's a fraction less than 1, that means that this is going to be a reduction. So we can look at the same example. Look at side AB, which is a side length of 3. And then if you look at side A prime B prime, we have a side length of 1. So it went from 3 to 1. So that means it is a third of the size. Okay, so it was a reduction. And then to get that scale factor, we can actually determine if it was increased or decreased by the same amount on all sides. It is a true dilation. But if it's not, then that means it has to increase every single side by the same amount. If it's not, then that means it's not a dilation. And it'll tell us by setting up these ratios. So let's have a look at that. All right, here we have our first figure. We have this red pentagon. It has 5 sides. And we can see that all 5 sides are labeled as 3 units long. And then we have a blue pentagon here, and all of these sides are labeled as 1. So in order to see what happened, each side went from 3 to 1. So we take and we make a fraction out of every side, and we'll put the image, the new one, over the original. So that would be 1/3, 1/3, 1/3, 1/3, and 1/3. So 5 fractions, because each side is 1/3. There are 5 different sides, so we know that this one is indeed a dilation because every side decreased by 1/3. Now in example B, we have 2 triangles, and you can probably tell that, hey, something's weird here. This red one and this blue one, they don't look similar. Well, we can mathematically show that they're not as well. So we can take side PQ, which has 5 meters long, and then P prime Q prime, which is also 5 meters long. So that's 5/5. Well, that means that there wasn't any change to this side. So from P to Q to P prime Q prime, it says there was no change. They're the same exact size. So then we can look at from P to R. So from P to R, we have 7 meters. And then from P prime to R prime, we have 11 meters. So this fraction would be 11 over 7 because it's image over original. So 11 over 7. And then the last one, we have 5 centimeters from Q to R and then 10 centimeters from Q prime to R prime. So that fraction would be 10 over 5. So as you can tell, these three ratios are not all the same. So this one is not a true dilation because every side did not increase or decrease by the same amount. All right, so let's see if we can tell what the scale factor is given original point and then a new prime point. So we have the point 912, and then it tells us that A prime is 3, 4. So if we want to see the scale factor, if we want to find the scale factor, we're going to take the original values that line up. So remember, this is your X value and this is your Y. This is your X value and this is your Y. So we're going to take and make fractions here. So we're going to take the X value, which is of the image, which is 3. And put it over the original X value, which is 9, and then we're going to reduce that. 3/9 reduces to 1/3. And then we're going to do the same thing for the Y value. So 4 over 12. And does that also reduce? Yes, 4/12 also reduces to 1/3. So this one is indeed a dilation, and the scale factor by which it was dilated is 1/3. That means it got smaller. It got 3 times smaller. All right, number 2, the original figure B is at 4, 6, and then the new coordinates are at 2, 3. So we're going to set up those fractions again, starting with my B prime, 2 over 4. That reduces to 1/2. And then my Y values would be 3 over 6, which also reduces to 1/2. So this one has a scale factor of 1/2. I don't know why I wrote that, sorry. 1/2. So this one is also a reduction. The scale factor by 1/2, that means every side got half the size of the original. All right, number 3, I'm going to switch colors. Scale factor, we have point C at 1/4, and then C prime is at 5/20. So I make my fraction this time. I'm going to have 5 over 1, which simplifies to 5. And then my Y value would be 20 over 4, which also reduces to 5. So this one is a enlargement of a scale factor 5. That means every side got 5 times larger. And then the last one, D, our fractions would be 21 over 3, which reduces to 7, and 14 over 2, which also reduces to 7. So this one is a dilation. It was an enlargement. Every side would be 7 times larger from the original pre-image to the new image.